Persisting on the trend of electrolysis, in MCQ 15, we want to find out what happened to the ions that is moving to the negative electrode during the electrolysis of molten potassium iodide. So molten potassium iodide Ki would have the absence of water. So in the absence of water, we should not be expecting H+, we should not be expecting OH-. So the relevant cation here that is found in this electrolyte will solely be K+, molten. The anion would have been iodide, molten. Writing out the half equation at the cathode, without any form of selective discharge, K+ will be gaining a single electron to form a molten potassium. Iodide will be losing 2 electrons to form iodine vapors, balancing out with 2 in front of your I-. So the shortcut here is for negative electrode, we know that it will be attracting cations. So it's otherwise referred to as the cathode. I have always advised students to try to convert negative electrode to cathode and positive electrode to anode because this allowed them to use the shortcut of crayon that was taught in class. So crayon is often used in conjunction together with shoe. So for the case of crayon, we're looking for cathode, for C, R for reduction, A for anode, and O for oxidation. Shoe, we have plus, minus, plus, minus, minus, plus, minus, plus, and each of the row at the top is representative for oxidation, and E for electron, which is often used for electrolysis, and the plus is for reduction. So at the cathode itself, we should be looking for a reduction event that's happening, and that from shoe and electron perspective is the same as the act of gaining electron. So A suggesting that the ions are reduced are going to be true because that is what is happening at the cathode. B to say that the ions formed molecule is untrue because an atom is actually formed instead at the cathode. C, the ions increase in charge. Writing out the oxidation state, K+ started off with the oxidation state of +1, but elemental potassium now only have the oxidation state of 0. I'm actually looking at the decrease in charge and not the increase. And lastly, the act of releasing electrons is better rephrased as losing electrons, which is the same as oxidation. But we know that at the cathode, we are going for a reduction event over here. We should have been gaining, not releasing electron. The answer for the question here is A.